Hello friends, we're here with the 60s Gretsch Dual Twin back on the workbench. I did a little bit of work off camera here just to do some tests super quickly. So if you guys saw episode 1, it is 100% all original as far as I can tell, except for a 3-prong that was added, and then the switch was completely jacked. So you can see that. No, your eyes do not deceive you. It is open on one side for some reason, and the internals are completely busted. So the owner of this amplifier provided me a different switch, so I quickly, temporarily installed that just so I had kind of, basically I was just able to turn it on. And then I replaced the speaker wire, which was completely jacked up, with just some wire I had hanging around here, and ran that straight to the cab, which is off camera. You can see it kind of the edge here on my workbench, just so I could see if we're getting any output or anything. You know, plugged it in with the current limiter and the variac, slowly turned it up. No signs of a short or anything. That's good. We were getting voltage from the wall. Everything's good there. So then I plugged in a rectifier, you know, kind of did the general steps, made sure we're getting voltage elsewhere. Everything seemed okay just at first glance. So I put the tubes in it. Again, current limiter in the chain so we can, you know, see if there's an issue. No issues. And it was outputting sound. So that's awesome. And that brings us here to where we are right now. The switch, unfortunately, I didn't check it. I thought it was a 3-way like the originals, and it's not. It's a 2-way. So currently it's wired on, but again, that's going to be all changed. So I'm going to bring it up with the variac, and I grabbed a guitar just so we can quickly see, if there's any issues, just playing on it really lightly. And then from there, we'll kind of dive back into the amplifier, figure out what we need order, talk to the owner, yada, yada. But I wanted to film this part. So with that, let me go ahead and turn on the variac, and let's slowly bring up the voltage, and I'll plug in a guitar. All right, so we've got it up to 117 volts right now, which is what it calls for, at least here on the faceplate. I did check for the fuse, by the way. The fuse in it is fine. So we're plugged into the standard channel in the high input, and I don't know if you can hear there's a little buzz in the background, to be expected. But let's go ahead and, see if the controls are working okay. It's very simple, just a volume and a tone. And then this is the trem channel. We'll check that after. I'm going to have to... My shotgun mic always clips with any kind of decent volume, even if I pad it completely. It's just kind of weird. So I'm going to unplug the shotgun mic. We're going to get the camera audio from the camera itself. I'm going to pad it down, and then I'll just play. You won't be able to hear my voice, but it should be pretty self-explanatory here. But just to show it's working. So that's awesome. All right, let me unplug the mic. Cool. So I hope the camera audio comes across better than what the shotgun mic would. It would just be a distorted clipping mess. But yeah, this thing sounds awesome. So I did kind of, you can't see because the controls are kind of below here. But yeah, I kind of went from roughly halfway in the volume all the way up on both channels. The trem channel sounds great. Very, very cool. Nice and throbby. There's no depth control or anything. So it's kind of, this is just a speed knob over here. Interesting to me, the low inputs sound quite a bit gainier than the high inputs. So I don't know what that's about, but yeah, what a cool amplifier. Very clean overall. It does get a little bit of grind in the standard, but it's, I'm also using a Jazz Master, nothing, if you can see it, but nothing crazy here. So no humbuckers where I drive more, but yeah, just a really neat sounding amp with the 2x10 cab here too in the vertical configuration. It's very, very cool. So that's awesome. This thing, I mean, all the tubes are what came in it and they seem to be working fine. It's a pretty quiet amp actually. Obviously I'm standing next to the transformer. It's going to get some buzz, but other than that, it seems really, really, really good. And yeah, great condition and sounds like it's in the condition it looks. So very encouraging. Next steps, talk to the owner. I think we need to redo the 3-prong wiring and there's definitely leaky voltage on the pots there. You can hear as I'm turning them that they were crackling a little bit. It could be dirty pots as well, but I'm guessing there's probably DC from these old caps on there. We've got a couple caps here and there that we can replace, possibly the can cap, although again, I'm not hearing any noise. It seems to be in really good condition. So yeah, this thing's awesome. So we'll end there, and then I'll pick this up after I have more clear direction what to do next. All right, guys, we got the Gretsch Dual Twin here back on the workbench. There's been a couple updates. So first and foremost, this is now my amplifier, which I'm very excited by. Do I need another old amp that requires work? Absolutely not. But you know what? Here we are. I just think this thing is so cool. It's such a vibe. And once I heard it, I was like, yeah, I got to own this thing. It's too cool not to own. So yeah, basically I went over with the owner based off the first video. Here's what I think probably needs done to it. And he didn't want the work done. He kind of wanted to just replace the switch and be done with it. And then asked if I was interested in just buying it as is. And I said, sure, why not? So here we go. This is my new Gretsch Dual Twin. Heck yeah, very cool. And with that in mind, obviously there's some work that needs to be done to it. And we're going to figure it out. And I'm going to be a bit more experimental with this because it is now my amplifier. So the first thing I've done to this amp that I didn't really film because honestly, I just had a heck of a time. I was trying to figure it out. So you guys saw I wired up the 2-position DPDT switch that was given to me by the previous owner now as a replacement for the 3-position DPDT switch. Very confusing and hard to say name there. And I wired it up exactly like it was from the factory just so I could turn it on. And that resulted in on and on. There was no off position because I'm missing in the middle, which was the off. So now that it's mine, I wanted to clean up the 3-prong wiring a little bit. I'm not going to go overboard and do anything crazy with this. I don't have time to be honest, but I did want to just clean it up a little bit. So I did a little bit of modification and redid the 3-prong a bit. So we shortened the hot neutral so that the ground is longer than them. We ran the hot here directly to the fuse tip. And then from the fuse sleeve, this is just wire that was already in the amplifier running here to a terminal strip that was already here. And then another wire that was already here to go over to the switch. And then the neutral is going to this right here. And then again, another wire that was in the amp that was just repurposed. And that's going here. So we got the hot and the neutral. And then the ground, you'll notice I scuffed up the paint off of the chassis here and re-tightened this to make sure it's a really solid ground connection. So that's good to go. And then the primaries here off the power transformer are just connected to these two empty terminals. And then these were the extra wires off of the 3-prong that I cut off when I shortened it. And I just repurposed them here because I do not have any of this plastic coated wiring available. All I have is cloth covered fender style. So I've got to order some. And this is all temporary. I will redo this. But this thing gave me a heck of a time trying to figure out how to wire it up to get it to go turn on in the, up position. And I don't know if you guys have ever messed with a 6-pole DPDT switch with 2 positions instead of 3. it's very confusing how to wire it up, and more confusing because this amplifier has a pilot light that is runs off of mains voltage. So I'll show you in the schematic here what it looks like. Hopefully you guys will be able to see this. But yeah, so you can see here's the, the 2-prong, and then it goes over here and we've got the 6-position DP/DT switch here, and it's a bit confusing how this is all laid out. I could be misinterpreting it, but you'll notice that the neon bulb is all part of that versus it's not getting off of, a 6.3 volt tap off the transformer like you'd see on a Fender amp, for example, to power the pilot light, excuse me. Yeah, so anyways, that confused me quite a bit. Here's where we landed on that worked. We've got the hot and the neutral here. The bottom 2 poles are not being used. And then the middle pole is the 2 different leads off of the primaries of the transformer here. So this one's the black, this one's the white. They're the same. And then we've got 1 lead off of the pilot light and 1 lead off the pilot light. So again, hot, neutral, pilot light, power transformer, power light, power transformer, and that worked a treat. You'll notice this large disc cap that was connected here to one of the poles when it was wired the way it was from the factory. I believe this is just to kind of eliminate pops when you switch between off, reversed, and on. But I'm not sure exactly. I just left it here in case I want to do something with it, but don't mind that. Okay, so that's the work that's been done there. And then once I did that, and I hooked up just kind of 2 leads for this is the output transformer. It goes to the speaker and a ground connection for the speaker as well. And hooked that up and played the amp a little bit. I didn't record really any of it. I did record a YouTube short. If you guys are curious, you can check that out. But I played a good bit just around the house, and it sounds great. It sounds very good. And I wanted to see if any, issues would arise because, an amp that's been dormant for as long as this has, some things will pop up. Maybe it might not be immediate, but as things get voltage through them and kind of get the juices flowing, if you will, something might show it or rear its ugly head. And we did have some issues where some noise started coming in and we had some kind of intermittent issues and whatever. So to me, that's a good sign. It means, okay, there's things that we need to do to fix here. And that's great. We get to dive in and learn this, quite convoluted, crazy looking amplifier with all the colors of the rainbow and wires here. It's just such a schizophrenic mess, but I love it. Okay. All right. So with that being said, here are some things I learned about the amp and kind of some things I want to do to it. And then we're going to, just plug it back in and rock this sucker and see how it goes. But these are the things based off the schematic I noticed and also in doing some research. So the first thing that I noticed is, well, the amp does not have a ton of gain. It's actually fairly clean, even with the volume controls basically all the way up. It does not have a lot of gain or push to it. And basically, there's a few reasons for that as far as I can tell. But one of them, which was interesting to me, is again, I'm not sure if you guys will be able to see this or not, but the first V1 preamp tube, you'll see half of it is split between both channels. So this is the standard channel, this is the tremolo channel. And the standard channel has the cathode resistor here. This is the biasing resistor for the V1 for this half of the V1 12AX7 off of pin 3. It's a 2.2K right here, which measures just fine. These are all high quality resistors, and everyone I've checked is measured basically dead on. So that's good to see. These were actually built with good parts. These are solid disc caps as well that I really expect no issues from. Anyways, the first thing that people do to these that makes total sense is adding a bypass cap. So a cathode bypass cap right here. And this will increase the gain. And that's something you see on, all Fenders basically, for example. So I will be putting in a 25 microfarad 50 volt cap here. Now you could do other values and kind of experiment with it a little bit, but I think we'll do the standard value of 25, 50 as a starting point. We can kind of play with that a bit down the line. Now, if we go over here to the treble channel, or not treble, sorry, the tremolo channel for the other half of the 12AX7, this is pin 8, and it does have a cathode bypass cap here, 35 microfarad 50 volt. That's right here. So that's the only one in the amplifier. And then it does have a different bias resistor. So it's a 1.5K. So those are the differences. Well, there's more differences, but those are the first immediate differences between those two channels. So that's the first order of business we'll do, is we'll just add in a bypass cap there. And then we've got the bias circuit. So the bias circuit, we'll go over here. Where am I at? Right here. So this is the power tube 6973s, very interesting tubes. And we've got the 250 ohm resistor, as well as the 35 microfarad 50 volt bypass cap or bias cap. So we will be replacing this bias cap with, I'm not sure what value yet. I got to see what I have in my inventory, but something probably in the 50 microfarad range. And we will try and figure out how to, what the bias of this is at with the 250 ohm. Now this amp is expecting 117 volts from the wall. It is obviously cathode biased. So at 120 volts, I'm not sure where that's going to put us exactly. What I do believe is that this is not biased very hot naturally. These tubes I think can handle quite a bit. They're pretty powerful tubes, these 6973s, but we also don't want to burn them, right? So these are very expensive, fairly rare tubes. Nobody, I don't think, really makes a modern equivalent, at least not to my knowledge. So we will be checking that out. And then looking around a bit more, another spot that was identified that I've seen people talk about is the off of V2 here, the 0.0003 cap and the 1 meg to ground. So here's the 1 meg to ground, and then here is what should be the 0.0003, but in fact this amplifier has a 0.0033. So people talk about removing those altogether or increasing the cap value. So that's something I might experiment with after I do this bypass cap first to see kind of what difference that makes, but that's something on my radar as well. And then looking at everything else, so like I said, lots of high quality disc caps. I'm not expecting issues there. All of these little coupling caps, these are all 0.05s. You can see one here, 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 and here. Now we'll check for those. We'll check those to kind of see if there's any leaky voltage or anything, depending on where they are on the circuit. This one's got some grime on it, so we'll probably replace this one, but I'm not too worried about those off the bat. We will definitely circle back to those, but off the rip, I think those are fine. And we will probably replace this bypass cap here. I don't know if I mentioned that, the 3550. And then the last thing that's kind of immediately on the radar is this can cap. So this is I think it was let me check the schematic. I believe it was a 10-10-20. Yeah. So it is a 10 microfarad, 10 microfarad, 20 microfarad can cap, 450 volt. And I'm not sure which one is which just by looking at it here. However, I think we'll probably put in discrete caps using a terminal strip and this bolt right here, which is just so much available space here. So I think that probably makes sense to utilize it and install some nice discrete components, based off of what I have here. Now I do have lots of 20 microfarad, so I might do just triple 20s on this and see how that sounds, just to play with it a little bit. I don't know enough about this circuit really to know if going to 10 and 20, I don't think that's going to make a big enough difference to be an issue, honestly. So we'll probably just go ahead and move forward with that and do 3 of these to replace this can cap. And then once all of that's done, we'll play the heck out of it and see how it sounds and tweak it where we feel like it might need to be tweaked. But yeah, I'm just really stoked on this project. I just was so inspired by the tone, especially with my Jazz Master. And I plugged in my, I didn't record this, but I plugged in my Deluxe Memory Man into it. And it was just a beautiful, warm tone, fairly clean, but just very unique. And I really like that. So we're not going to tweak it too much to get outside of that, just kind of hone it in a little bit and play around. So, all right, that was long, but thanks for sticking around, or maybe you just skip this entirely with the timestamps. All good either way. But let's go ahead and move forward. We'll turn on the soldering iron and get to soldering with the components I have now, and then we'll kind of play with it from there. All right. So upon further review, I actually decided to move the terminal strip over here. Now, I can already imagine a few people saying that that's the wrong move. However, everything is already laid out here, the wires, so I think it just makes it a bit easier to hook up. In addition, all of these can be bent out of the way, so there's nothing touching, and I've moved it away from the metal side of the chassis here, so there's no really concern about arcing there. These will be bent out of the way, so really there's no concern. And then I'm not using this middle lug for the ground connection for the caps. Those will be going over to the probably this connection right here, if not these ones as well. So lots of options, but I just think this will be make it a bit tidier and yeah, have everything kind of more or less in the same place. So let's go ahead and first move these leads over to their own terminals here. So these two will go to this one will go here, and then this one will go there. And then this one right here is just a ground connection, so not something I'm really worried about. So, all right, let's go ahead and do that. All right, if I don't get hate for this install, I don't know what's going on. But look at it, the amp is crazy in itself. So yeah, it will work. Now, there is a slight chance that, grounding here versus having all three ground at the same point could be an issue. Whether this is a noisy ground or not, I don't know. Everything is just riveted here all across the amplifier. So this connection here is off the output transformer as well as the power transformer here, both of the grounds. So yeah, I don't know. We're going to go with this. And if it's, causes issues or whatever, we will learn from that and move it around to somewhere else. But I think for now it's totally fine. So let's go ahead and move forward here, and we will be siliconing these two together and then siliconing this one to the chassis. So let's get that prepared, and we'll silicone this one first and then solder it in. All right, so these leads are definitely strong enough to hold these caps up, no problem. They're not, there's nothing to bang up against. There's some wires below them, but you can't silicone them to the wires. So this will just hold them together, but they're pretty solid together, so I'm not really worried about that. And then this one is silicone to the chassis. So awesome. I'm really happy with how all of this came out overall. Let me zoom out a little bit. So those are our discrete components now. So those are our main filter caps done in this amplifier, and that just leaves us with a couple cathode bypass caps. So let's take care of those real quick. We can take care of this bias cap here. So this is a 35 microfarad 50 volt, and I will be replacing it with a 50 microfarad 50 volt here. So that'll be going right there. And then we will also be adding in this cathode bypass cap, a 25 microfarad 50 volt over here for pin 3 of the 12AX7 in V1. All right, check that off the list. Let's move on down. So here we have V1. I mentioned this before. This is the biasing resistor for the half of the 12AX7 for the normal channel, and it does not have a bypass cap. Whereas the vibrato channel does. The tremolo channel, you can see it just, you can't see, let me zoom out. Just right here. So this is the cathode bypass cap for the trem channel, and that is ultimately connected over to the to pin 8 here, which is this yellow lead, which goes here, then that goes across the bypass cap and then over to the pot there. So here we have the 2.2K for the normal channel, so we're just going to go ahead and add a bypass cap right here, bridging this connection from pin 3 over to ground. So let's go ahead and do that. And for this, we'll use a mod 25 microfarad 50 volt. Beautiful. So there we go. That's it for tonight. So just to recap, replace the 3 main filter caps, replace the bias cap here, and then the cathode bypass cap we added here for channel 1, the standard channel, just to gain that up a bit. Now there's still work to be done. I do intend on changing out these cathode bypass caps. I've got these 0.047 microfarad replacements here, but I only have 4 of them. And there's 1, 2, 3, 4, 5 that need to be replaced. There's also a bypass cap down here that still needs to be replaced. And yeah, this calls for 35 microfarad 50 volt. So I'm debating on whether I want to throw a 25 in there or not, or go with something a bit bigger. So for now, that's going to stay the same. But overall, very happy with where we're at. So yeah, we'll end there tonight. Tomorrow, we will probably fire it up just to confirm everything's good to go, and then install the new coupling caps, at least 4 of them. All right, let's end here and pick it up tomorrow. All right, it's a new night, and I've already checked the amplifier for a dead short. I used the current limiter and the variac, brought up to voltage. No issues, nothing popped up. So I took the variac and the current limiter out of chain, or plugged directly into the wall. And we're going to go ahead and check the bias real quick. Now, I don't know really with these 6973 tubes what their wattage rating is. When I looked it up, I was a bit confused on the results. It seemed like I was getting different numbers. So I'm going to have to figure this out after the fact, but I just want to document the numbers now, and we'll figure that out. So we're going to be checking the bias, basically doing the cathode resistor voltage drop method. So the first thing we'll do is check the actual ohms rating here. If my multimeter wants to work. There we go. So we'll let that measure real quick. This is just to kind of see where we're at right now. So we got, using the Rob Robinette calculator here, we've got 2 tubes sharing the cathode resistor. The resistor value is about 253.4. So let's go ahead and check what the voltage across the cathode resistor is. So we're gonna go ahead and fire it up and see what we got. We'll switch over to DC volts here. And we, everything looks good. So let's go ahead and turn it on. We do have the volume controls off. So that is pin 9 on that tube, I believe is a plate. And we are seeing 340. All right, so I let it warm up a little bit, and yeah, we're just kind of hovering around 343. So I'll probably do 343.1. That seems to be the middle ground between the numbers there. So 343. I'll just do 343 actually. So we'll have 343 there. I'm going to use a 6v6 as the baseline tube. As far as I know, these tubes are fairly similar. The pinout's different, yada yada, but I think they're fairly similar to 14 watt 6v6s. So that's what we'll use as the baseline. And now, carefully, excuse the popping, that's my phone being close to the amplifier here. And then the voltage across the cathode resistor, we're looking at 21 point, let's say 35. And that's putting us at 97.9% plate dissipation per tube, assuming these are roughly 14 watt tubes. So that seems like a pretty good number to me. And that's at the wall voltage. So I'm pretty happy with that for a cathode bias amp. You want it to be, you know, obviously around 100%. And yeah, okay, I feel pretty good about it now. So we don't have to worry about the tubes too much, at least as is. Well, you know, we might fine tune the bias a little bit, but for now we're good to go on that. So now that that's out of the way, yeah, let's go ahead and see how it sounds real quick. Now, just like before, my shotgun mic is just not going to be able to handle it. So I will unplug the shotgun mic. We'll use the stereo camera mic here with the cab just off screen. You can see it right here. And I'm not sure how well it's going to sound, but we're just going to try it. And I will do a more proper demo of this thing. But yeah, feeling pretty good. So let's go ahead and do that real quick. Holy crap. Wow, massive difference there. Yeah, this mod right here of installing that cathode bypass cap really made this channel 1 come alive. So it's interesting, these inputs here, you got a high and a low, but it's a bit counterintuitive. They don't seem like high and low inputs, certainly not like you would expect on a Fender or a Marshall or a Vox or anything like that. It seems to me that the high is actually a high pass filter channel, to where it's cutting out a lot of low end and letting more top end through. It's a much thinner sounding channel. So those are these two. And then the low seems to be just normal, as far as I can tell, a lot more girth, more gain. And yeah, this channel right here, standard channel, no trem, in the low input, quote unquote, is a rocker, man. It seems quite a bit louder than it was before. Seems healthier. The amp seems like it's gained quite a lot of volume actually after doing all that work to it. I'm very impressed. It seems quite quiet as well. Obviously, I'm standing next to the amp, wide open on a bench with a guitar, so it's going to be a bit noisier than it will be inside the cabinet. But damn, this thing is sick. I'm super stoked on it. So yeah, I feel pretty good about that. Next steps, I'll probably check for some leaky voltage here and there. I've already ordered some replacement parts to be able to replace these these coupling caps as needed. I'll probably just replace all of them, to be honest, but we'll do that once we get the parts in. So for now, I think we'll go ahead and end here. This thing is awesome. I'm super stoked on it. And yeah, thanks so much for watching. If you liked the video, give it a thumbs up. Let me know what you think. And until next time, see ya.